Hi everyone. In this video, I'm going to be going over the topic of volume and capacity. I put these two together because finding the capacity is basically the same as finding the volume, and then you just convert the units at the end using one of the conversions that we've talked about. So I'll get into that in a bit. Now, this is from the Year 11 course on measurement, and really is broken into two halves. There's volume and capacity, and there's also surface area, which also pops up a fair bit. So I'll do another video on surface area later. So anyway, let's go right into the syllabus points. To solve problems involving volume and capacity, solids including prisms, cylinders. So cylinders are just basically circular prisms. Spheres, so we need to know the formula for that. Pyramids, need to know the formula of that. And composite solids. Composite solids obviously meaning, different shapes being, either cut out from each other or added onto each other. We also need to convert between units of volume and capacity, which we'll get into in a second. Then calculate the perimeters and areas of irregular shaped lands using trapezoidal rule, and then use the trapezoidal rule to find the volume of water in swimming pools. So hopefully you guys are pretty good with trapezoidal rule. It's just the same formula, you use it. But then I want to do a couple of questions where we then got to talk about finding the volume on top of that from like catching water. Catching water is a very common one of that. And then lastly, solve problems involving perimeters, area, surface area, volumes, capacity, and a variety of contexts. So you'll see that, we'll talk about types of HSC questions in a second. So reference sheet and formulas. This is where a lot of formulas are given to you. So let's just quickly go over them. And remember, on the reference sheet, it only tells you the formula. It doesn't tell you what the formula is for. So this is a formula for a sector. All right, we know this because you see the pi r squared and you think, okay, well, that's obviously area of a circle. And then so this theta over 360 is like the fraction of the circle that makes that sector. Theta being the angle that's in the middle. And this here, this is for trapeziums. All right, so that's a trapezium. So h over 2, h being like you can kind of refer to as the horizontal distance between the two parallel lines, or the height of the trapezium, and a plus b being the two parallel lines. And then so here's the trapezoidal rule. That's the trapezoidal rule, and remember, it's got the little approximately equal to signs, which is really important when you're doing those questions. But you'll see that it's exactly the same formula as trapeziums, hence why it's called trapezoidal rule. And then other things we have, I'll talk about, like I said, I'm going to do another thing on surface area later, but we have these two formulas for volume. So this is for pyramids. And what this means is it's 1/3 times the area, where area, like that A, is the area of the base shape. So if we have like a square pyramid, for example, the volume of that is going to be the area of that square that's on the bottom, times it by the height, which is at h, and then finding 1/3 of that. And then, so looking at this one, 4 over 3 pi r cubed. So the pi r cubed should be a hint in itself. We know pi r squared is circles, so pi r cubed is spheres. And then you got the 4 over 3 as well. So that's for spheres. And of course, if we're trying to find the volume of a hemisphere, so half a sphere, we'll just halve that at the end. The one volume that's not sitting on here on the reference sheet is V equals AH, and that you can kind of get it from there, but this is for prisms, and this pops up quite a bit and also throws a few people off. So what this means is you get the area of the base shape. Remember, a prism is basically some shape, so maybe like a triangular prism, and it's kind of like pushed into 3 dimensions. So to find the volume of that shape is I'm going to find the area of that base shape, that triangle, for example, and then times it by the height, okay? Now, before we go any further, it's really important that when you're using any of these formulas, you always have them written in the same units. Now, it's not always going to be exactly the same units. For example, where we have the volume A times H, all right? That area, of course, might be in meters squared, and the height has to be in meters then. So then like there's meters squared and meters, but as long as they're the same like magnitudes, are still meters. So what we can't have, for example, is have the area in meters squared and have the height in centimeters. You will need to make a conversion, and as you go through it, you'll find there's a lot easier to convert the height rather than the area. So there's that, and then looking at the exam difficulty and frequency. So you're probably going to get like one question on volume and capacity, and if you know all the formulas and you know how to use it, and you can kind of just take away all the information you have in the thing, it's generally pretty easy. But obviously it's easy once you know it all. So what I'd suggest you do is just do a bunch of questions on volume and capacity as well, to just get comfortable with using all the different formulas. And then you, like you see here as well, they might also have some reverse questions as well, where you get given the volume and you need to find a height. So you need to do some like division or something as well. So these kinds of questions are difficult, if not impossible, if you don't know how to use these formulas and you don't remember the other formulas that aren't on here, like volume of a prism. But once you get familiar with those formulas, you find that it's just, okay, which one do I have, and go from there. So with that said, and I guess I should say, the questions for this chapter are also typically written to be on the trickier end. I'd say that these are generally band 5-6 questions. Anyway, so let's go into this first set of questions, 2008 question 25C. As always, if you haven't already, pause the video, have a go at this question so you can then check your answer as you go along. So pieces of cheese are cut from cylindrical box with the dimensions below. So we just have like this cheese wedge. 12 pieces are packed into a rectangular box. There are 3 rows with 4 pieces of cheese in each row. The curved surface is face down with the pieces touching as shown. So we have this box which we put the cheese pieces in. So first we need to find like what are the dimensions of this rectangular box. So dimensions, what that question and what that's saying is, what's the length, what's the depth, and what's the height, all right? That's what we mean by dimensions. The question's not asking me to find the volume of the box or anything like that. It's just asking for the dimensions. So we can see a few straight away. We're told that, first of all, let's look that this is a sector. You can kind of say that this is like a sector prism. So it's a sector that's just then times it by 7 to make it a sector prism. So you can see that the height of this piece of cheese is 7. So that means this depth is just going to be 7 plus 7 plus 7. So this is just going to be 3 times 7 here. Then looking for the height of this box, well, we see that this shape, we see the radius is 15 centimeters, and that's 15 centimeters. And because that's a radius, that means any line that I draw from the center to the outside is also going to be 15. So that means this line here is going to be 15 centimeters. So that's 15. So the last thing that we need to find, and this is going to be where it's, this is where it gets a little bit tricky, is we now need to find this length. Okay. So obviously straight away we have 4 of these, so it's going to be 4 times something, but we need to find what that something is. What we need to see straight away is it's not going to be the curved surface. That's not what we're trying to find. We're trying to find this horizontal distance, because we're just finding like the width of that piece of cheese. So if I can find that, then I'll just times by 4 to get the width of this, or the length or whatever you want to call it, of this box. So let's just draw what we basically have here is a triangle. So let's just draw that triangle. Okay, so we have 15, 15. It's a radius, so that makes this isosceles. And we have 40 degrees in here, and I'm trying to find x. All right, so I have this triangle, 3 sides, 1 angle. So yeah, we're going to be using cosine rule, just because this is volume and capacity. I mean, we do see that's 4 marks, so there's going to be quite a bit of work to this. So let's set up the cosine rule. We have x squared equals 15 squared plus 15 squared minus 2 times 15 times 15 times cos 40. When you put that into your calculator, you'll get 105.28000 . So obviously, last thing we need to do is square root that. So x equals 10.2606 ... So we found the width of these pieces of cheese. Now, again, I just want to reiterate what I haven't found this curved edge. That would be the arc. The way that I could find that arc is using the arc length formula. L equals theta over 360 times 2 times pi times the radius, because 2 pi r is a circumference and then it's just a fraction of that. But yeah, we're not trying to find that curved surface. We're trying to find that straight line, the width of that piece of cheese, which is that. So now we have this is 4 times 10.2606 ... And of course, like all questions, and it's like particularly important when we're doing these volume questions, you don't want to be rounding until you get to the end of the question. So we've now found basically all we need. So we'll say that the height, the question is, remember, it's asking for the dimensions. It's not asking me to find the volume of the box. Obviously, if I was trying to find the volume of the box, I'd do length times breadth times height, but that's not what we're doing in this case. So the height here is 15 centimeters. The length, as we saw here, is 4 times 10.2606, blah, blah, blah. So when you do that, you'll get, let's just do it to 2 decimal places. It didn't tell me what to round it to, so I'm just going to do 2 decimal places, so 41.04 centimeters. And then the depth, well, that's just 3 times 7, so the depth equals 21 centimeters. And there we go. Now, you know, some people, like, which one is the length, depth, or height? You know, it could be debated. Like, if you might say that this is width or breadth or height or something like that. It doesn't really matter what name you give it. There's no real standard defined name for each of the dimensions. As long as one of them said 15, one of them said 41.04, and one of them said 21, you're good to go. Okay. So that was 4 marks, and it's a little bit of a tricky one as well, because you're needing to think about all these different pieces, and then this 3 times 7, and realizing that the radius is the same everywhere, doing a bit of cosine rule, a whole lot in just one question. And then looking at this one, part 2. So to say packing space, the curved section is removed. So they've just chopped off this little bit. What is the volume of the remaining triangular prism of a piece of cheese? Answered to the nearest cubic meter. Well, what we have here is now just this same triangle that we had earlier. And so we want to find the volume. Now, like I said, this is just a triangular prism now. So to find the volume of that prism, volume is equal to A times H, where A is the area of that base face. And that's how volume for all prisms work. So find the area of that base face, in this case it's a triangle, times it by the height, which is 7. So to find the area of this, well, this is a non-right angle triangle, so we have our area formula, half times 15, half AB times C. So half times 15 times 15 times sine 40. And if we times that by 7, we'll get 506 point ... Oh, you get something. So what you get is this becomes 72.3136 ... And we're going to just be timesing that by 7. So therefore the volume ends up being 506 centimeters cubed to nearest centimeter cubed. So centimeters cubed, cubic centimeters, whatever. The question's telling me the answer to the nearest cubic centimeter. So we have 506 centimeters cubed. And that's all using this volume formula for prisms. Volume is the area times the height. All right, so that is a fairly tricky question, particularly for this one. We're using stuff from non-right angle triangles, both cosine rule and the area formula, but you should be comfortable with that. You should be looking for, like, wherever possible or wherever required, to utilize things from different topics when solving questions. Let's go to the next question. So a cylindrical water tank of height 2 is placed on the ground at school. The radius of the tank is 3.78 meters. The hole is 2 meters deep. When the tank is placed, they want a 1 meter gap all the way around the tank as well. So when digging the hole for the water tank, what volume of soil was removed? So first of all, what we need to realize is we have this cylinder in here, this white cylinder, which is the tank itself. And then it says they want a 1 meter gap all the way around it. So what they've done is they've dug a bigger cylinder around it. It has the same height, 2 meters, except the radius is going to be a little bit bigger. Here, the radius is going to be equal to 4.78. The reason why is the original radius of the tank is just 3.78, and then we're adding another 1 meter. Now, we obviously don't want to add it 2 meters. Like we're not worried about the whole diameter. We're only worried about the radius, because I'm trying to find the volume of this big space that's being cut out. And then so a cylinder, like I said, is basically like a circular prism. So therefore, volume can be found with that same formula I was talking about, A times H. Okay? Now the area in this case, in this prism, is that circle that's on the top. So we've got pi times, and then the radius squared, 4.78 squared, times it by the height, which is 2. And that gives me 143.5607 ... So that's 144 meters cubed to the nearest meters cubed, which is what the question asked me. Give your answers correct in just cubic meter. Remember, you don't want to lose silly marks just because you didn't do that. Next is sprinklers are used to water the school oval at a rate of 7,500 litres per hour. The water tank holds 90,000 litres when full. But how many hours can the sprinklers be used before a full tank is emptied? So this doesn't really have anything to do with volume and capacity, even though it is talking about litres. This is just a rate question. So we're saying it's watering at 7,500 litres per hour, and we have that many litres, so we're just going to divide. 90,000 divided by 7,500 equals 12. So therefore, if the tank is full, it can water the school oval for 12 hours. And it's only 1 mark, so fairly basic. And then lastly, 2 marks. Water is to be collected in the tank from the roof of the school hall, which is an area of 400 meters squared. During a storm, 20 millimeters of rain falls on the roof and water is collected in the tank. How many liters of water was collected? So this is a question that I want to focus on because it does come up quite regularly, particularly it's talking about catching water on a roof or something. So the idea is we have some kind of roof and it's not telling us what kind of shape it is. So I'm just going to assume it's some kind of like rectangle or whatever, or a square. And we're told that the area of this is 400 meters squared. All right. And then we're told that we got 20 millimeters of rainfall. So you can kind of imagine this being a prism. It's a rectangular prism. All right. So where that height is 20 millimeters. So using our volume formula for prisms once again, it's just going to be the area times the height, except what, like I was saying earlier in the video, is you can't just do 400 times 20 because these aren't the same units. One of them's in meters squared, the other one's in millimeters. So what we need to do is we either need to change this area to be into millimeters squared, or we need to change this height into meters. Now, I find it's a lot easier to change this one dimension, this length, rather than the area. So our volume here is going to be 400. So the area times 20 millimeters is equal to 2 centimeters, which is equal to 0.02 meters. So I'm just going to do 400 times 0.02, which equals 8 meters cubed. All right. But that's not what the question is asking me. The question isn't asking me to find the volume. I need to find the amount of liters that was collected. Now, something I probably should have mentioned earlier in the video, but we have two conversions for changing volume to capacity, two ones that we can use. The first one is 1 centimeter cubed equals 1 milliliter. All right, so that's a pretty basic one. So if you have your question in centimeters cubed or centimeters, that means you can just change that to milliliters. And the other conversion that we have is 1 meter cubed equals 1,000 liters, which is also 1 kiloliter if you want to write it that way. Okay. These are the two conversions that you need to know, and neither of these are on the reference sheet, so both of these are incredibly important for you to know, because they might not be told you in the question. Sometimes it does tell you, remember that 1 meter cubed equals 1,000 liters, but you need to know these conversions. It does say that on the syllabus. So therefore, this is 8,000 liters, right? Because I found 8 meters cubed, that changes to 8,000 liters. The question was asking for how many liters. If the question was asking for how many kiloliters was stored, well, then it'll just be 8 kiloliters, because 1 meter cubed equals 1 kiloliter. All right. Going into the next question. I've chosen this one because it uses trapezoidal rule. Now, in the question, it did originally say Simpson's rule, but this is back in 2009, back when that was in the syllabus. It's no longer in the syllabus, so I'm just going to trapezoidal rule. So here we got this lake, and we got this picnic area. And part one is we want to find the approximate area of the lake surface. So to do this, if we're able to find the area of this whole rectangle and then find the area of each of these little parts, I could do the area of the rectangle minus the area of the white parts, which would give me the area of the lake. And the way that we're going to find the area of those white parts is by using trapezoidal rule. So I'm going to call this area 1, area 2, area 3, and area 4. You don't want to try and combine these. So area 1 is approximately equal to, so here we see our height of area 1 is 12, or the h is 12 over 2, and then the first distance is 35, and the second distance is 22. So just using our trapezoidal rule, the idea is like we've got some trapezium that we're using to approximate that. And then when you put that into your calculator, we find that the first area is equal to 342. Now, I'm not going to bother going through the working for each of the other ones, but it's just the same thing, 12 over 2 times 22 plus 30. So area 2 is approximately equal to 312. Area 3 is approximately equal to 150. And area 4 is approximately equal to 90. So that means the total white area, the total curved area, so total white area, and just be descriptive. I mean, like, obviously in a real world, we wouldn't be calling this the white area, but, you know, if we're referring to this question, just say it's the white area. So that's approximately equal to 894 meters squared, and that I've just done that by adding all these together. Now what I need to do is find the area of this whole rectangular bit. So rectangular area. So the height of this rectangle is, as you can see on this side, is 35 plus 20, so that's 55. And then the width of this rectangle is just 12 plus 12, so 24, which gives me 1,320 meters squared. So therefore, lake area is approximately equal to, and again, we need to use approximately equal to because it's based on approximations we had here. So it's going to be 1,320 minus 894, which is 426 meters squared. Okay, making sure that we're using approximately because we are finding an approximate area. It's based on our trapezoidal rule, which gives us approximations. And then part 2. So the lake is 60 meters deep. Bozo, the clown, thinks he can empty the lake using a 4-liter bucket. How many times would he have to fill his bucket from the lake in order to empty the lake? So this is similar to that roof question that we just did a second ago, where we now have this area of this water, body of water or something, and then we have like a height associated with it, that's 60 centimeters. So again, what I want to do is I need to find the volume of this thing first of all. So the volume is going to be approximately equal to 426, the area of that lake. But again, I'm not going to times it by 60 because that's 60 centimeters, but that's meters squared. So let's just change that to be 0.6 meters. And now we can just times that by 0.6. So that's approximately 255.6 meters cubed. Now we have that, and we're told in this question this time, and this is what I was saying a second ago, sometimes we'll tell you the conversion. So note that 1 meter cubed equals 1,000 liters, and we're trying to find like how many, we're trying to find the capacity of this lake first of all. So therefore the capacity is just going to be that times 1,000. So that's 255,600 liters. So that's how many liters are in the thing. But the question is asking how many times I'm going to need to fill up this bucket. And it's a 4 liter bucket. So therefore I need to do 255,600 divided by 4, which equals 63,900 times. And that might seem really wrong. Like it seems like a ridiculously large number, like considering that we're talking about the amount of times I need to fill up a bucket and get it away. But I think that's kind of the point. The not so subtle calling Bozo the clown, making him sound like an idiot, which he would be if he was trying to empty this lake with a tiny little bucket. Anyway, that's just the NASA and the HSC writers having a little joke, very funny. Anyway, last question, last page is 2 multiple choice questions, and I just want to give you an idea of what they can ask in multiple choice. So we have a swimming pool as a length of this and length of 6, depth of 5, or width of 5, sorry. The depth of the pool is 1 meter on one side and 3.5 meters on the other side. And this is all shown in the diagram. So what is the volume of the pool in cubic meters? So this is a trapezoidal prism. So the idea is if we can find the area of this trapezium at the front, and it might be helpful to just draw that trapezium as well. I think it's always a good idea to draw that base if it helps, because we have 1, we have 3.5, and we have 6. Now, this 6.5 actually isn't needed in this question at all. For this trapezium, all I need is the length of these 2 parallel sides and the length between it, the straight horizontal length between it. So 6.5 isn't going to help me at all. So the area of this trapezium is just going to be 6 over 2 times 1 plus 3.5, which equals 13.5 meters squared. And then lastly, to find the volume, I'm just going to get that. So the volume is the area times the height, as we've been talking about throughout this video, which is just 13.5 times that 5. So that's going to be 67.5 meters cubed. The answer is A. And secondly, this question, so during a flood, 1.5 hectares of land was covered by water with a depth of 17 centimeters. How many kiloliters of water was in? So again, I just want to do this question again, where we have like this area, and we're talking about like rainfall or something like that. We're trying to find how much water was stored or whatever. So we have 1.5 hectares, and we're told that 1 hectare equals 10,000 meters squared. Now, you might not necessarily be told that in a question. If you need to remember what 1 hectare is, a hectare is 100 meters by 100 meters. That's how we calculate a hectare. And then, so how do you find the area of that? Well, it's just 100 times 100, which is 10,000. Okay, so that's where that comes from. It's really important that you remember that, because if they ask anything about hectares, they might give you that conversion, they might not. And they've also told us 1 meter cubed equals 1,000 liters. Okay, and 1,000 liters just happens to be 1 kiloliter. So we're going to probably use that later on when we're doing how many kiloliters. So we have 1.5 hectares. So 1.5 hectares, and the symbol for that is HA. That equals 15,000 meters squared. So that's just 1.5 times 10,000. Make sure you do 10,000, not 1,000. So therefore the volume, again, it's just area times the height, because we're kind of thinking of this as a prism. We've got this shape. It doesn't necessarily need to be a square or anything. And then we're adding 17 centimeters on top of it. So we have 15,000, and we're timesing by the height. But again, this is meters squared, but that's in centimeters. So I want to change that to be 0.17. And that's such an important point that, you know, I've now had to do that, I think 3 times in this video. It's so important that if that's meters squared, that needs to be in meters. And then when you put this into your calculator, you get 2,550 meters cubed. And then using this question, we're then told that 1 meter cubed equals 1,000 liters. So we have 25550,000 liters. And then the question is asking me for kiloliters. So the trick here is people might just go ahead and say D. That would be right if we're talking about liters. We want kiloliters. So kilo means 1,000. So I'm just going to divide this by 1,000, which gives me 2,550 kiloliters. So the answer is this. Now, like I said here, 1 meter cubed, we're told is 1,000 liters. And we know that 1,000 liters is 1 kiloliter. So you can just remember that 1 meter cubed equals 1 kiloliter. So I could have just jumped straight from this to this as well. All right. Anyway, hope that this video has been useful. I think you'll find that, you know, going through these questions, a lot of it comes down to that sometimes it is a bit harder where you need to apply things from other topics such as trigonometry. But like questions that you can be expecting, like trapezoidal rule, finding volume of prisms happens so often. And then also thinking about like rainfall and talking about, you know, the amount of water collected from like some rain or something, making sure you think about conversions between volume and capacity. Anyway, if you have any more questions about this topic, be sure to ask, and thanks for watching.